Welcome to Calculus 1. Today we're going to review how to evaluate functions. But before we do example on how to evaluate functions, let me define what a function is. Now before I can define what a function is, let's take a look at this particular word called a relation. A relation simply means any set of ordered pairs. Okay, it's a set of bunch points, and we normally denote them as in a brace. Okay, maybe like a -1, 2, 5, 3. Okay, it just simply means a set of ordered pair. That's called a relation. Maybe like a 7, 2, something like that. Okay. All right. So what is so-called a domain? Okay, domain of the relation is a set of all first components of the ordered pairs. So my example up here, the domain will be -1, 5, and 7. It's the first component of the relation, and the range of the relation is the set of all second components. Okay, so a lot of times we say domain is referring to the x values, of your function, and the range is referring to the y values of your function. All right, so here's an example. For domain and range, it's just the first component, which is x. Second component is y. So what is called a function? A function is nothing but a correspondence between the domain and the range, such that every element in the domain corresponds to exactly one element in the range. Okay, every element in the domain corresponds to exactly one element in the range. Okay, that's called a function. Okay, 1x corresponds to 1y. Another way of saying this is actually saying that you can't have the same x value in a domain that have two different y. Because if you think about it, if the two x values are the same, the two y values are different, that will actually create a vertical line. And in a college algebra class, we call this the vertical line test, because only the vertical line has the same x value, where the y values are different. So for a graph to be a function, it got to pass the vertical line test. All right, where we cannot have the same x value. If we do, the graph is actually not a function. Now, to evaluate a function, a lot of times it can simply means we will input an x value and output a y value. The input value will be the independent variable. The output value will be the dependent variable. So when we normally evaluate functions, what we're really trying to do is substitute an x value, so we can actually find the y value. Now we don't always have to just substitute a particular numbers. We can actually substitute variables and such. So let's say here we have a cubic function, and a cubic function generally looks something like this, and it will pass the vertical line test. Okay, so that means anywhere on this cubic function there's no same x values. All right, so let's substitute a 3 for x, and let's see what the y value is. So for part A, f of 3, we will substitute 3 for x. That will be, I will substitute my 3, put it inside the parenthesis to the third power, minus 3 times 3 squared. All right, and 3 to the third is 27, minus 3 squared is 9. 9 times -3 is another -27. So my y value will be 0. So this output will be the y value, because I just substitute an x value into the function. So if I will graph this function, x raised into the third power minus 3 times x squared. If we graph it, this is a cubic function. If I go to my table, and go down to x equal to 3, and you will tell me my output or the y value is also 0. So my answer after I evaluate representing the y value. Now another way I can evaluate functions, besides doing it by hand or come to the table, I can also click on second calc, choose number 1 value, and simply type in x equal to 3, and you'll give me my output y equal to 0. Okay, so we got 3 basic ways we can do this. Alright, let's try part B, where we got to substitute x minus 1 into my function. Alright, so let's do a little bit of algebra here. Alright, substitute x minus 1 for x, so that will be x minus 1 whole thing to the 3rd power minus 3 times x minus 1 whole thing squared. Alright, so the subtraction sign here tell me that my expression has 2 terms. For my x minus 3 whole thing squared, we can do binomial expansion, or we can excuse me, simply multiply this out. So I know x minus 1 squared, using the perfect square binomial, I can figure out that real quick. And excuse me, then we will times another x to the, we'll times another x minus 1. So that will make it x to the 3rd power. Alright, x minus 1 whole thing squared. Perfect square binomial tell me that's going to be x squared minus 2x plus 1. Take that, multiply by x minus 1. And let's just multiply this thing out. Alright, x squared times negative 1. X squared times x, that's going to be x to the 3rd. X squared times negative 1, negative x squared. Alright, negative 2x times x, negative 2x squared. Negative 2x times negative 1, positive 2x. Alright, positive 1 do a distribution here. 1 times x, positive x. And 1 times negative 1, negative x. So if I combine like term, I believe this is going to be x to the 3rd. Negative x squared minus 2x squared, negative 3x squared. Oh, excuse me, I did not mean to write negative x here. That's negative 1 right there. 2x plus 1x, positive 3x. And a negative 1. Alright, so my first term come out to be x to the 3rd minus 3x squared plus 3x minus 1. Alright, my second term here in the expression, negative 3 times x minus 1 whole thing squared. Well, I know x minus 1 whole thing squared give me this. Now we just need to times by negative 3. So negative 3 times x squared, negative 3x squared. Negative 3 times negative 2x, positive 6x. And I get a negative 3. Combine like terms. X to the 3rd, got nobody to combine with. Negative 3x squared minus 3x squared, negative 6x squared. (3x plus 6x), positive 9x. And I have negative 1 minus 3, negative 4. Okay. Alright, so that's it. This is a simplified answer. So we can substitute a number into my function, or we can substitute an expression where we had to simplify it. Alright, I'm gonna try another example here. Evaluate this function x squared minus 7 at this expression. Okay, so if you look at this expression here, the f of x part is the same as this. Okay. So whenever I'm coming to this part, I will just write x squared minus 7 here. So the front, substitute f of x plus delta of x. Okay. So let's figure out that part real quick. Substitute x plus delta of x into my function. X plus delta of x. So that will be, take this, substitute for x, that will be x plus delta of x, whole thing squared, minus 7. And again, here I can use the perfect square binomial. As if you don't remember, perfect square binomial says a plus b whole thing squared will just be a squared plus 2ab plus b squared. So for me, that would be x squared plus 2 times your a times your b. That will be 2x times delta of x plus b squared, delta x got to be squared, and then we minus 7. Alright, so there's no like term to combine. So all these guys go at the beginning. So I'm just gonna copy and paste it right here. So all these guys, okay, go at the beginning minus a squared minus 7. These two terms, it's gonna be in the parentheses when I write it here. So use a -1 to do a distribution. That will be minus x squared plus 7, whole thing over delta of x. Alright, combine like terms. I think the x squared term will cancel out. -7 plus 7 will cancel out. So the only thing left on top will be 2x delta x plus delta x squared over denominator delta of x. Alright, since the two term on top, both of them have delta of x, I can factor out my delta of x. So that will leave me with 2x plus delta of x. And once I make the top into one term, I can now cancel it out with my denominator. So the delta x will cancel out. So my final answer will just be 2x plus delta of x. There you go. Okay. Alright, that will conclude this video. Thank you for watching.